Okay, let's dive right in. We're going to go under the hood and explore the incredible non-stop engine that powers your every single move, your cardiovascular and respiratory systems. We're going to see how your heart and lungs work together in this perfect harmony to fuel, well, your entire life. So let's get into it. Just think about this for a second. Whether you're a world-class athlete pushing the limits or you're literally just standing up from your couch, that one simple action kicks off this unbelievable chain reaction inside your body. It is an amazing internal journey that happens in a blink of an eye.
So have you ever stopped to wonder how that actually works? How does your body get the exact right fuel to the exact right place at the exact right time? Well, that's the fascinating story we're going to dig into today.
And our story really begins with the most essential fuel of all, oxygen. I mean, before it can power anything, it has to get inside the body in the first place. So first up, let's trace the pathway of air. Every time you take a breath, air comes in through your mouth or your nose and travels down your trachea, that's your windpipe. From there, the path splits into two big branches called the bronchi, one heading to each lung. Now, think of it like a tree branching out, because that's exactly what happens. These bronchi just keep splitting into smaller and smaller tubes called bronchioles, and they finally end up at millions of tiny, delicate little air sacs called the alveoli. And this is where the real magic starts.
So the air has officially reached its destination deep inside the lungs. And now comes probably the most critical moment in this whole process, the handoff. This is the spot where the air we breathe finally, physically meets our bloodstream.
And here they are, the alveoli. You can honestly think of them as your body's super busy loading dock. It's right here that all that oxygen you just inhaled gets loaded onto red blood cells for delivery. And at the same time, the waste product, carbon dioxide, gets dropped off so you can breathe it out. But for this whole exchange to happen so fast, the alveoli have to be perfectly designed for the job.
And oh, they absolutely are. Their design is just genius. First, their walls are unbelievably thin. We're talking just one single cell thick, which lets gases pass right through, super easily. Second, if you were to lay them all out flat, they have a massive combined surface area. And third, they are completely wrapped up in this dense web of tiny blood vessels called capillaries. It is the perfect setup for a fast, efficient exchange.
So how does the oxygen know where to go? It's all thanks to a really simple rule of physics called a pressure gradient. The best way to think about it is like a super crowded room opening up into an empty hallway, right? People are just going to naturally move from the crowded space to the open one. It's exactly the same with oxygen. Your lungs are packed with it, but the blood showing up is running on empty. So the oxygen just naturally flows from the lungs into the blood. No effort required from your body at all.
And this chart just shows you the result perfectly. The air you breathe in is about 21% oxygen. But look at the air you breathe out. It's only about 16% oxygen. So what happened to that 5% difference? That's the oxygen your body just grabbed. It's the proof that the exchange is happening, right now, with every single breath you take.
Okay, so the oxygen has been loaded into the blood. Now what? Well, it needs a way to get to every single cell in your body, from your brain to your big toe. And that's where we meet the cardiovascular system, your body's own incredible superhighway. Now, this highway is basically made of three different kinds of roads. First, you've got your arteries. These are the major freeways. They've got thick muscular walls because they have to handle the high pressure of blood being pumped away from the heart. Then you have the veins, which bring blood back towards the heart. Their walls are much thinner because, well, the pressure is way lower. And finally, you have the capillaries. These are like the tiny little neighborhood streets. Their walls are just one cell thick, connecting the arteries and veins and allowing that crucial drop-off of oxygen into your body's tissues. Let's really zero in on that difference for a second. Arteries are a high-pressure system. That's why they have to be so thick and strong. Veins, on the other hand, are a low-pressure system. And because that pressure is so much lower, they have this really clever adaptation. Tiny one-way valves that make sure the blood keeps flowing in the right direction and doesn't decide to flow backwards. Pretty smart, right? All of these highways, these roads, they all lead to and from one central, unbelievably powerful hub. It's the engine of the engine, the heart. So the heart is basically this incredible muscular pump with 4 rooms or chambers. You've got 2 atria at the top, those are the receiving chambers, and 2 ventricles at the bottom, which are the main pumping chambers. A simple way to remember it is the right side of the heart handles the deoxygenated blood, and the left side handles all the fresh oxygenated blood. Let's trace the actual path. All right, hang on, let's follow a drop of blood. Deoxygenated blood coming back from the body enters the right atrium. From there, it gets pumped down to the right ventricle, and then whoosh, it's sent off to the lungs to pick up that fresh oxygen we were just talking about. Now, this newly oxygenated blood comes back to the left atrium, gets pumped into the super powerful left ventricle, and then bam, it's shot out through the main artery, the aorta, to get delivered to the rest of your body. And then that whole cycle starts all over again every single second. So we've seen how air gets in, we've seen how blood gets around. Now let's look at how these two amazing systems cooperate and adapt, especially when we start to put our bodies to the test. You've probably seen numbers like this at the doctor's office, right? This is blood pressure. The top number, the systolic, that's the force on your artery walls when your heart contracts and pumps blood out, the push. The bottom number, the diastolic, that's the pressure when your heart relaxes between beats, the rest. It's a really key indicator of how hard your whole system is working. Now, this is just brilliant. When you start exercising, your body needs to get way more oxygen to your working muscles, and it needs to do it fast. So it performs something called vascular shunting. It literally redirects blood flow. It constricts the blood vessels going to areas that aren't important right now, like your digestive system, and it widens the vessels going to your active muscles. It's an incredibly smart and efficient way to send resources exactly where they're needed most. When you look at the whole picture, what this all shows us is that nothing in the body ever works alone. The journey starts with a simple breath, sure, but that one breath is connected to the pump of your heart, the flow of your blood, and the final contraction of your muscles. It truly is one beautifully connected, intelligent system. So the next time you take a breath or feel your own heart beating, maybe just take a second to appreciate this incredible, automated engine working tirelessly inside you. It really makes you wonder, if all of this is happening just to power a single movement, what other mind-blowing things is your body doing right now, completely behind the scenes?